I can go back to the first one, de-energize, energize, de-energize, back to the first one, energize, de-energize, energize. So from any switch position, I can do the opposite function. I can turn that off here, turn it back on, I can turn it off here. Turn it back on, I can turn it off here. I could turn it on there, so energize, I can de-energize here, or I can de-energize here. So this is what's referred to as four-way switching or three-way, four-way switching. By adding a four-way switch in the middle, I can have three different locations to energize or de-energize my light fixture. What I'm going to do is I'm going to take my ammeter, my clamp-on ammeter, connect onto current, and we're going to follow the path from our power supply to our light fixture. Our outputs of our three-way and inputs of our four-way, output of our four-way, input of our three-way, those connections there will be referred to as our travelers. So basically the red and blue wires will be our travelers. We have our line coming into the common of our first three-way, and we have switch leg from our second common three-way, and then we have identified from our light fixture. Okay? So we have power on our power supply here. I'm just going to energize my light, and I'm going to see once I clamp onto this, I don't know if you guys can see that. Let me just put this over here. On the live conductor coming in, I have 0.3 amps. So I know I have current on this black wire. All right. Coming out of my three-way switch, I have either a red or a blue wire. We're going to see which one has current on it. Let's check the blue wire. It does. It has 0.3 amps on it. So there is current coming out of our three-way on the blue wire. There is no current on the red wire. Okay. So of these two travelers, my blue one has current on it. It is bringing current from my three-way into my four-way here. Okay. At my four-way, these two would be my inputs. These two would be my outputs. So since I have current on this blue wire from my three-way, I'll see if it's the red or the blue of my four-way that has current on it. Let's check the red wire. It does have 0.3 amps on it going out. My blue wire does not. So I have current coming into my four-way switch on the blue, going out on the red to my three-way switch. Coming into here, obviously there is no current on the blue wire, which I've already verified. And I have current coming into the red, and it should be going out on the black, on the three-way, on the switch leg, coming into my light, and then coming out on the identified, I also have current there, coming all the way back to my power supply. Okay. If I change this switch position, we'll see that we have current still coming in on the live conductor. From my three-way, initially I had current on the blue, now I do not. I have current on the red right here. So current is coming out of my three-way, going into this terminal of my four-way. Okay. So I have current at this point here now. I have current coming out of my red wire here. So I have current coming in on the black to here. It is now on this red wire from my three-way to four-way. From my four-way to my three-way is on this red wire. And then I have current again on my switch leg going to my light fixture and I will have current on my identified going back to my power supply, being my bench. So I can track which wire, which set of travelers I actually have current. Whenever I change positions, when I go to this position now, I don't have current going. If I change position of just one of my switches here, I can follow the path of current one last time from, I have current coming in on my live conductor. This switch I haven't changed position, so it should still be on the red. So I have current coming in on the black of my three-way, going out on this traveler to this location. Originally we were coming out on the red wire to my three-way switch, but now we have current on the blue wire of my four-way. So now there's a connection diagonally here. Instead of originally I had current coming in here, going out here to my three-way. Now it's going diagonally between this red and this blue to my three-way switch, and of course coming out of my three-way, the common, the switch leg, going all the way back to my load, my light, and going back to my supply on my identified. So I've been able to track my current flow from my power supply going out, following my travelers through my three-way, my four-way, my three-way, back to my light, all the way back to my power supply. Perfect. I'm going to disconnect this. I'm going to do a different lab. Now we're going to do what's procedure 4. We want to be able to have two different switches. Actually, I'm going to do procedure 5. We're going to do 3 switches controlling 2 lights, but I'm going to have 2 lights be on all the time where none of the switches control them whatsoever. So I'm just going to disconnect from my bench just to be on the safe side, and I'm going to eliminate this light fixture here, because now I'm going to have a total of 4 lights. I'm going to have 3 switches control 2 lights, turn them on and off, energize and de-energize, while the other 2 lights are going to stay energized all the time. All right. So I'm going to take out my really pretty set of lights here. We're going to control these 2 red lights with 3 switches, while these 2 green lights stay on all the time. And again, you should be able to draw a schematic version of this circuit here. I'm just going to connect, first of all, bond wire to my light box here. Okay. So what we're going to do, I'm going to just move this a little bit further back so I can make all my connections here. You should be able to see where I was connected, where I came out of my second 3-way switch to my previous light. I'm now going to connect it onto this light. I'm going to jumper light 1 to light 2, so both of these lights will energize simultaneously. I'm also going to jumper the identified side. So what I'm doing now is I'm connecting these 2 lights in parallel and connect them back to the identified power supply. Oops. All right, so right now I have these 2 lights are in parallel with each other, and these 3 switches are controlling 2 lights simultaneously. But now I want to be able to keep these 2 lights on all the time, energized, while these 2 are being switched. Okay. So in order to do that, then I forgot to connect my initial common 3-way back to my power supply. From my power supply, and this will be on your schematic, on your left-hand side will be your power supply, connecting onto the black terminal here. because these green lights are going to be simultaneously coming on together, I am going to parallel the black connections. I'm also going to parallel the white terminals, and also on the two green lights make a connection back to power supply being the identified connection. So these two green lights can represent, for example, two plugs or receptacles that they stay energized all the time while we are switching just these two lights from 3 different locations. Okay, so let's see if all this works, if I have all my connections correct. So when we turn this on, we have everything on. These two kind of very bright there, and I know it's kind of freaky looking, kind of give you that Christmas appearance. The two green will represent, for example, like 2 plugs being energized all the time. We're going to control the 2 red ones. So from here we can de-energize the 2 red. You see the green ones are staying energized. The red, now I can energize, de-energize, energize, de-energize, energize, de-energize, energize, de-energize, re-energize. So the whole time we were switching the lights, the 2 red ones, the green ones were staying energized all the time. Okay, this could represent, like I said, receptacles in parallel, and these are 2 light fixtures in a hallway or a stairwell. Perfect.